Okay, so I wanted to do three stories tonight, but two of them are closely related, and we've talked about this before. In fact, the last meeting we had in November, we talked a lot about one of these. So the Commercial Crew Transportation Program is what is intended to be the successor to the space shuttle for NASA in terms of transporting crew members from the ground to the International Space Station. So when we knew that space shuttle was being retired back in 2010, NASA started this program to partner with commercial entities to build essentially space taxis that NASA would purchase seats on to carry astronauts to and from the ISS. And so the two successful companies were Boeing and SpaceX. And back in 2010, it was expected we'd be flying these things routinely. In 2015, 2016, we're still not there. And we can talk sometime about why that happened, but it's basically the short story is Congress holds the purse strings, and if they say you're going to do this, we're not going to give you any money, but you're going to do this, then things tend to slide. So this is the two spacecraft that are being tested as we speak. So here's the ISS, this is the Boeing Starliner, and this is the SpaceX Crew Dragon vehicle. And so a number of things have happened since we last got together. I think where we ended up last time is a test had been done of the Starliner, a pad abort test it was called. They want to be able, if the crew is on the spacecraft waiting to launch on the launch pad and something goes wrong with the rocket, they want to be able to escape from a failing rocket on the ground. And so Boeing did this test. It worked just fine with the exception of one parachute didn't open. And they understand why that happened. So the next test is an orbital flight test where they actually launch an uncrewed version of this, have it automatically dock with the space station, and then return to the ground as an end-to-end test before they put astronauts on board. So just to get a feeling for the scale, here's the Starliner spacecraft being prepared before its launch attempt, and I'm going to do this manually, I guess. So this gets its ride to orbit on a United Launch Alliance Atlas V, and this is an artist's drawing of what this looks like. So here's the crew capsule, service module that gets carried into orbit that has all the propulsion and the life support systems, and then here is the rocket. And so on the 20th of December, this first test of the Starliner was intended to launch. The idea was it would, over the course of about a day and a half, after launch, fly to the space station, automatically dock with the space station. It would stay there for about 8 days, and then it would return to the Earth. And so it comes down on parachutes. It lands on land, as opposed to the ocean, as all other American spacecraft other than the space shuttle have. And on the way down, it pops a very robust set of airbags and plops down in New Mexico as the preferred landing site. And so here's the logo for the orbital flight test. And looks like an artist's drawing, but this is actually the real thing. This was from the top of the assembly building, looking down on the Starliner and the Atlas V as they rolled the whole stack out to the launch pad a couple days before launch. And here we are on the pad. It's a very sort of peculiar looking stack. You don't have this nice nose cone covering the payload like you normally would on a satellite. And so here is launch day, and I'll show a short video of how this all proceeded.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and liftoff. The rise of Starliner and a new era in human spaceflight.
Clear the tower. Now 10 seconds into flight. Vehicle's begun the pitch over program. Body rate responses look good. Now 15 seconds in. PU's gone to closed loop control. RD 180 looks good at full thrust. Seeing good chamber pressure on both SRBs. Now 26 seconds into flight. RD 180 now throttling down to partial thrust as expected. Engine response looks good. Now 38 seconds in. RD 180 engine operating parameters continue to look good. Vehicle is now passing through max Q, maximum dynamic pressure. Chamber pressures on both SRBs continue to look good. RD 180 engine operating parameters also continue to look good. Now passing 1 minute into flight. And Mach 1, Atlas V is now...
Okay, so that was just the first minute of launch, but launch went perfectly. But as soon as the spacecraft separated in orbit, it was supposed to fire its onboard engines and slightly raise its orbit so that it could stay in orbit and not re-enter the atmosphere. And what ended up happening is as soon as it cut away from the launch vehicle, it started firing its onboard thrusters semi-wildly. And the ground realized that it wasn't behaving the way that they expected it to. And they took over manual control, but as luck would have it, as they sent up the commands to stabilize itself and increase its speed in one direction, it passed between coverage of two different communication satellites. And so there was about a 6-minute gap in communications. When they regained communication with it, they were able to get it in a stable orbit, but they realized it had been doing this very frequent firing of its onboard thrusters, and it had expended a substantial fraction of the fuel that was on board. And so they quickly realized that they did not have enough fuel to actually make it to the ISS. And so they ended up staying in orbit for 2 days and did a lot of just on-orbit tests to prove the entire system. So on the 22nd, 2 days after launch, they did the normal return from orbit to White Sands Missile Range in New Mexico. And so that's what's this next video.
And we see 3 main chutes.
So this is, again, at night.
Billowing up, we have...
So this is an infrared view of the Starliner descending.
3 main chutes. We see the red, white, and blue as Starliner descends.
So this time all 3 chutes opened.
3 seconds from touchdown. And the rotation handle has deployed.
And so the first thing that happens here is they drop the heat shield.
Base heat shield has jettisoned.
And then the airbags inflate on the base of the capsule.
And that is the last of the milestones. So now all that's left is for Starliner to float down to the surface of the desert in New Mexico. Everything continuing to look good on this camera that we're getting from the WB-57 cameras, infrared cameras, giving us as good a view as we could expect at nighttime.
And so this is as it's getting closer to the ground. You can, I guess they have spotlights on.
Just 300 meters left to go. That's 984 feet. Very close now.
On the spacecraft that are illuminating
20
the
seconds.
parachutes.
20 seconds to landing the first Starliner flight test vehicle.
They obviously don't plan these for primetime television. So there it's on the ground.
And Starliner touches down in the desert in New Mexico. An historic landing in White Sands, New Mexico concludes the first flight test of Boeing's Starliner spacecraft. The first time an American-made, human-rated capsule has landed on land.
That took place right at 6:58 a.m. Central Time, 2 days, 1 hour, and 21 minutes into Starliner's mission.
All right, so just a few still images of this. There's the color image of it shortly before touchdown. Here it is sitting on its airbags. And just a couple of other, just because they're really nice pictures. This is a view from the launch pad, or near the launch pad. And what I wanted to point out here, you see these lines. This is actually sort of a spider web of lightning arrestor cables. We have these two lightning towers, essentially 250-foot tall lightning rods, and they connect those with conductive wires. And there's a big gap in the middle, so the rocket launches through the hole in the middle of the web of wires. And that is pretty obvious in that view. And then this next one is just because that's a really pretty picture. It was shortly before dawn, so the sun was just coming up, and it's pretty spectacular.